Okay, welcome back. Good morning, good afternoon, good evening. So we have a new topic that is rectangular components of force, somewhat related to our previous topic before, the finding the components of force using the parallelogram method. So in this case, it's a special case of the parallelogram method or parallelogram law. So the parallelogram is a rectangle. That's why it's called rectangular components, which means that the axes where the components are located are perpendicular. Okay? So perpendicular yung mga axes natin. So x and y axis. So for example, we have a force and we are to solve for its components along the x and y axis. Nasaan yung ruler ko? Okay, so we simply draw. So applying the parallelogram law. So, drawing lang tayo ng rectangle. Bakit black itong red? So from the head of the force, we draw parallel lines relative to the axis where the components are located. Okay. So ito yung components ng forces natin. Ito. So components along x and y axis. So let's say this is fx and this is fy. So there is fy, parallel siya dito. So that means this is also fy. And this is also fx. Parallel din siya. Same direction, same length or magnitude. Yan. So if we are to solve for the component of this force along x, so the force is directed at a certain angle from the x-axis. Let's say angle theta. So you can isolate any of the two triangles formed here. So applying the trigonometric functions. So if you solve for the component along x, fx is equal to, so fx is equal to, so we have a right triangle, so perpendicular yung mga axis, which means this is a right triangle. So we have a right angle, so we have a right triangle. So this is the adjacent side. That means fx is equal to f. Kapag adjacent, cosine of the angle theta. Ni-red mo ito sa akin. And fy, so this is the opposite side, which means that fy is equal to f sine of theta. So ganun lang, kasimple. So if you want to solve for the component of f along x-axis, of course given that the angle is from the x-axis, measured from the x-axis, then fx is equal to f cosine theta, adjacent side. This is the opposite side, which means that fy is equal to f sine of theta. Next, so what if the slope naman yung given, no? Slope, rise and run. So given ay rise and run. Tapos meron tayong hypotenuse na d. How do you solve for the components along x and y? So let's say for example, ito yung component niya along x and then component along y, fx and fy. So same pa rin, rectangle. So the parallelogram is a rectangle. Hindi naman na siya, extend tayo ng konti doon. So given yung slope ng force natin, so we solve for the components using similar figures. So itong slope niyan ay same siya dito, ano? Yung triangle na yan same dito. So if you want to solve for fx, that is equal to, so similar figures, it's equal to f times, since we are solving for x, yung horizontal, x over d. Okay? That's fx. And fy is equal to, since we're solving for the vertical component, vertical. So fy over d. So this is how we solve for the components of, rectangular components of the force. Okay. Given angle or yung slope. Okay, so very simple, easy. Okay. So let's have an example. Let's try to solve the first problem in your module. Okay, let's solve problem number 1 in your modules. Determine the x and y components of each of the forces. We have 4 forces. Let's solve for the components of F1 first along x and y axis. So, i-separate na lang natin yung F1 from the entire force system. So, what would be the component of F1 along x-axis? Let's say this is F1x, and then component of F1 along the y-axis, let's say that is F1y. Okay, so how do you solve for F1x? F1x is equal to F1x. So F1, adjacent side, that's cosine of the angle theta. In this case, we have 70 degrees. So F1 is 120 newtons times cosine of 70. So F1x is equal to 41.042 newtons. And the same is true dun sa F1y. F1y is equal to F1 sine of the angle theta. F1y is equal to F1, which is 120 newtons sine of 70 degrees. So F1y is equal to 112.763 newtons. So this is the component of F1 along x, and then component of F1 along y. We can solve for the components directly using your calculators. So if you have a calculator similar to mine, dali lang isolve yung components niya using your calculator. So i-press lang natin yung shift minus. So ilalagay natin, i-convert. Actually, kapag meron kayong background dun sa solid mensuration, pwede natin, this is actually a polar coordinate. Pwede natin i-convert yung polar sa rectangular coordinates, no? So i-convert lang natin, ilagay lang natin yung magnitude, which is 120, comma, yung angle from the x-axis, that is 70, then press equals. Now we have yung component along x is 41.042, yun. Then component along y is 112.763 newtons. Yeah, that's how you solve for the components using your calculators. Now this is true kapag ang angle natin is from the x-axis. Ang values would be different kapag ginamit natin yung angle from, kapag galing yan sa y-axis, magkakabaliktad yan. Anyway, we have a problem like that later on. So we'll try to use this function of your calculators later on to solve the components of F4. Okay? So, yun. Madali lang. Next, let's solve for the components of F2 along X and Y axis. Okay, letter B. Components of F2 along X and Y axis. So let's try to again isolate F2 from the rest of the forces. This is F2. Given naman yung rise and run, yung slope ng line of action of F2, so 5, yung vertical, horizontal is 12. So how do we solve for the components of F2 sa X and Y axis? So F2, first is we need to solve pala yung hypotenuse ng right triangle D. So how do we solve for the hypotenuse given yung dalawang sides is equal to, so we have 5 squared plus 12 squared. So the hypotenuse is equal to 13. Then solve for the components along X and Y axis. So solve for F2x is equivalent to, so horizontal, 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 horizontal. So F, which is F2, which is 390. Tama, 390 times horizontal, that is 12, all over the hypotenuse, which is 13. So F2x is equal to 360 newtons. So that is the component along X, and F2y, so y vertical. So vertical, we're going to use the vertical dimension. So we have 390 times vertical over the hypotenuse, that's 5 over 13. So F2y is equal to 150 newton. So these are the components along X and Y axis. Okay, next, F3. Solve natin yung component ng F3 along X, then component along the Y axis. Okay, next, letter C. Solve for the components of F3 along X and Y axis. So, it's quite similar to F2, given yung slope. Ito kasi given yung dimensions ng triangle, ay ng rectangle. So if this 112 millimeters, is also 112. So this 60 rin yun. So we can solve for the hypotenuse of the triangle D by Pythagorean theorem. So we have D is equal to, we have 60 squared plus, square root of 60 squared plus 112.5 millimeter squared. So D is equal to, what is D? 7. So D is equal to 127.5 millimeters. So parang given na rin, given na yung slope ng force. Okay, so if you want to solve for the x component of F3, let's say F3x is equivalent to, so x is horizontal, kunin nyo lang yung horizontal dimension, which is 60. So that's F3 is equal to 221 times yung horizontal over the hypotenuse, which is 60, over the hypotenuse is 127.5. So the component along X is nasa na 104 newtons. Okay. Next is F3y. So we have 221 newtons times y is vertical. So put nyo lang yung the vertical dimension ng triangle over the hypotenuse. So we have 112 0.5 divided by the hypotenuse 127.5. So the vertical component is equal to 195 Newton. So these are the components along X and Y axis of F3. Okay, last yung component of F4 along X and Y axis. Okay, so letter D. Sa case ng letter D, the direction of F4 or the angle is measured from the y-axis. So our initial derivation before sa formula natin to solve for the components would be different. So using the parallelogram method, form tayo ng rectangle. So if you want to solve for, so you can analyze any of the two triangles formed here. So ito yung force natin, F4. So drawing tayo ng parallel lines relative to each axis. So parallel line relative to X and relative to Y. So if this is F4 X, then this is also F4 X, since they have the same direction and magnitude. And then if this is F4 Y, this is also F4 Y. So you can analyze either of the two triangles formed dito. Okay, so since ito naman yung angle, then we can analyze this angle. So with that, it's a right triangle. So F4Y then is equal to, since this now the Y component is the adjacent side. Previously we have ang adjacent side natin is the X component because the angle is measured from the X axis. So in this case we measure the angle, the direction from the Y axis. So F4Y is equal to F4 cosine of the angle theta. In this case we have 55 degrees. So F4Y is equal to F4, which is 150 times cosine of the angle theta 55 degrees. So F4Y is equal to 86.036 newtons. And F4X, now the X component is now the opposite side, so sine. So we have F4 sine of the angle theta. So F4X is equal to F4, that's 150, times sine of the angle theta, that is 55 degrees. So F4X is equal to 122.873 newtons. Okay, so those are the components. Now you can use yung calculators niyo to solve for the components. Sabi ko kanina magkakabaliktad lang sila. So again, shift, hindi ata malinaw sa camera. Shift minus. So i-convert natin yung polar coordinate into an equivalent rectangular coordinates. So ilagay natin yung magnitude, that's 150, comma, and the angle, that is 55 degrees, equal, so lalabas yung components, kaya lang magkakabaliktad yan. So yung X component natin is actually our Y component, and yung Y component natin is the X component, kasi ang basis natin before is the direction or the angle is measured from the X axis. Yan. So you can also use this, so make sure na babaliktarin nyo yung values. Okay, so if you have questions, you may post your questions sa comment section, or you may post your questions sa group chat natin if you have queries or questions. I'll see you sa next video. I think maybe we can have one more example sa sa next, one or two more examples sa next na video natin. Okay.